Alright guys, so today we're going to be graphing -2 to the power of x or some fucking shit, I don't really know. Alright, so firstly we're just going to start off with a basic exponential, so y equals 2 to the power of x. Now if you're not familiar with this, I'd recommend giving up now. Alright, so next we're going to go with -2 to the power of x, right? And as you can see, Desmos doesn't really like it that much. So what are we going to fucking do about it? Well, it's actually pretty simple. First, we got to figure out why it doesn't like it very much, and the answer is fractional indices. Let's just say, hypothetically, for the sake of the argument, you know, we say x is equal to 2, so that should just be right here. Fuck. Alright, there we go. Alright, x is equal to 2, right? So yeah, right here. This is the point of intersection. Our y value is going to be 4, given that x is 2. But what the fuck happens when we go 1/2? Well, that's another way of saying square root. And for some reason, Desmos doesn't like complex numbers, so you're not going to get yourself a nice fresh answer. So, that's the problem. It's not going to graph anything that is a fractional indice. I mean, it might. But most fractional indices, I don't think it's going to. So, what the fuck do we do to get around this? Well, this is pretty simple, actually. So, firstly, we know we can graph all the integer values of x, so we can say, let's make this a function. There we go. Yeah, I know what I'm doing. Alright, f of x is equal to that, right? Remember that, because I'm not. Alright, so now we're just going to say, make a parametric tt. Look at that. Ooh, isn't that beautiful? I'm kidding, I just realized we can't make parametric. It's gonna have to be a list. So let's just say b is equal to the list. We'll go -10 to 10. That'll do. Alright, so now what do we do? Well, we just go b. As you can see, it is just like graphing the parametric, or you know, like fucking xx, right? That's that. But what do we do if we want to have, just make the function. It's pretty simple. Alright, so once we make it a function, as you can see, this is basically what it looks like, all the integer values of anyway. Now, if you're an idiot, you might actually fall for something along the lines of y equals, you know, 2 to the x times cos pi x. Because you'll notice, and I'll get rid of these to make it a bit clearer for you, you'll notice that every one of these fucking points lies on this wave. Therefore, some sneaky malacca might actually trick you into believing that this is an equivalent function or some shit, because you are a fucking idiot and can't, you know, figure out for yourself that the values between these integers simply don't exist in the real world. What do I mean by real world? I'm not going to explain in this video, I might do it in another video. But anyways, we're going to continue. Get rid of this bullshit. Alright, so what the fuck do we do next? Well, I think it's quite a simple solution. We go to the Argand diagram. Alright, so firstly, multiplying complex numbers, right? Let's say, you know, you have binomial a plus ib, you know, standard fucking Cartesian form. Actually, this one's going to be x plus yi. Ignore the fact that it's not graphing because, you know, this is just our working out, right? So we're going to get a times x plus a times y times I plus xbi, and then, you know, you're actually going to get fucking, there we go, minus yb. Now why are we going to get yb? Why is it going to be minus? Because I times I is fucking negative I, 1 there. I don't want those, get them out of here, get them out, there we go. Alright, so continuing on, we've established this. Now, if we can take two complex numbers, now imagine for a second here that this is the Argand diagram. I'm just going to, I don't know, slap in AB, it's our first complex number, define that. Oh shit, I just realized B is a list, C. Replace all these. Alright, get that out of here. Alright, so A is there, we've got to define B as well. Now we can drag around a complex number in the Argand diagram. X is real axis, Y is imaginary axis, obviously. If you didn't know that, get out. Alright, so now we're just going to go X and Y, and that, I just realized these aren't going to be too happy because X and Y is a thing. So we're just going to say X1 and Y1, you know, little subtext. Alright, now we got two complex numbers. But what is the multiplication of the two complex numbers? Well, we just go back to our little working here, and it's this looking thing. So we can just, you know, copy and paste this into that, and then I'm going to copy and paste that, move it over here, get rid of this, Okay, so now you get your y values, take away i's, just all the I terms of y values, and ones without I terms of x values. Shit, that's gotta be subtext, 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 subtext. There we go, right? So if I make one of these points, you know, I, which would just be its y value 1 and its a value 0, as you can see, it is a 90-degree rotation, so we can see that it's sort of working, right? What we can also do is we can define, you know, some points, you know, so capital A is that, capital B is that, and capital C is that. Next, what we can do is we can make some cool parametrics. So we do that, and we're going to go AT, fuck, wrong one, BT, alright, there we go, and as you can see, that is clearly a right angle in between those two. So it's working nice and well. And as you can see, -1 roughly is just a reflection. Ooh, anyway. What the fuck am I going with this? Yeah, right. So if we want to square the same complex number, right? Let's say a plus bi again. And you know, we just square, you get a squared plus 2abi and then minus b squared. As you can see, I think that's right. I'm kind of rushing myself here because, you know, I'm just... Alright, anyway, then, you know, you can go a squared, comma b squared, no, that's wrong, plus minus b squared. Alright, there we go, 2ab, that should be it. Alright, so theoretically this is squaring, the... Which one is it? Okay, it's a. Alright, so now we can go at. I'm gonna make this d. This is equal to d. Alright, what does dt look like? dt. So it should just be squaring the number, right? That is... Which one's a? A. It's the blue one. Ooh, is it? AT. Have I got AT? Should have AT. Oh, it's the red one. There we go. And the blue line is the squaring of it. So as you can see, yeah, it looks pretty legit. Alright, now we're basically, yeah, no. God, I'm trying to remember how I did this. The rule of thumb is, you know, we're just gonna multiply by like. Alright, so we're gonna take Alright, so we're back with a new fresh little slate. We're gonna do polar because now we're gonna be doing complex numbers in polar, mod-arg form, whatever the fuck you wanna call it. So a convenient little way of doing this, you know, you do parametrics, right? Like that, you get your circle, that is like the unit complex circle, right? We're going to represent a complex number, say for example cos A, sine A, and B, right? Alright, so what do these values mean? Well, in mod-arg form, you got your modulus, your argument. Your modulus is basically your magnitude, right? So, you know, I'm actually going to make a second one of these and just add a T in here. A little sneaky, bet you didn't see that coming. Alright, so your modulus is basically just distance between the complex number and 0. And you know, you can change the size by doing this. You know, changing B, or, you know, in this form, right? And you can change the argument, which is just the angle from the positive x-axis, going to pi like that, and going to negative pi like that. So it's actually between negative pi and positive pi, which I thought was interesting when I first learned it. Also, I'm going to set the range for these as pi and negative pi, because that's fitting. You know what's not fitting? Oh, fuck. Let me drag however I want. It won't let me. Okay. So, you just have to use these sliders like a fucking chump. Alright, so what do we do now that we have this established? Well, we can develop ourselves a little formula from the previous little bit we did on, like, you know, multiplying complex numbers. Now, if you have done Extension 2 maths in Australia or just done any education anywhere else in terms of maths, you'd probably know mod-arg for multiplication rules, right? you know, say we want to multiply complex numbers a and b, which I shall make equal to like that, and b is equal to like 1, 2. Alright, say we want to multiply these complex numbers here. What do we do if we're doing it in mod arg form? Well, let's go back to here, right? Basically, it's just a plus b, you know, you add the arguments, and you times the things to the modulus. There you go. And so, as you can see, now we'll do that proof thing again. You know what's funny? It's not actually changing these. Why? Because they're not capital letters. I'm a retard. Alright, let's go back. Fix up those mistakes just like this. Oh yeah, look at that. Look at that efficiency. Doesn't like it for some reason. Oh, you're right, I need to do it in mod arg form. Fuck. Okay, let me just fix things up real quick, cause a b sine ba like that, and then we'll do d and c, I guess. Alright, so d, c, c, sort of like that. For some reason, that's okay. Oh yeah, right, I defined these previously. Alright, whatever, just assign these. And you can... Ooh. Alright, cool. So if I change one of these, that's the argument. Yeah, okay, cool. Pi, negative pi. If we do pi on 2, that's basically I, right? And then you make modulus 1, that is I, right? So now what we should get is a 90-degree rotation if what we do works. So let's see if it fucking works. It probably won't, by the way, just heads up. BC, we'll change the modulus first. What's the other one's? D and A. D and A. I'm so funny. There you go, it's a right angle, and if I make that like C and CT. See how we succeeded at doing what we did last time and just sort of wasted our time? That's good, I think, I hope. Funny. Anyway, alright, so now that I have decided I want to kill myself just a little bit more, it's time to move on, right? If we're going to square it, I'm just going to refresh this new graph. Alright, if we're going to square a complex number, alright, you know, say we have like a is equal to x1, y1, that's our complex number, and it is right here. Alright, we're gonna need to convert into the old mod arg form. Of course, we are. Yeah, actually, yeah, no, yeah. Let's just make life easier and just not convert, because that's, you know, talking coherently or as much as I can, and doing math at the same time. It's multitasking, and I don't accept that, or appreciate that, or think I can do that. So M for modulus, A for argument, too easy. And as you can see, we can change the modulus and the argument just like that. Once again, I'm going to do what I have done fucking 5 times by now. And do that. Ooh, anyway, okay, cool. So now what we can do to get our product, you know what, we're going to make it capital P for product. And you know, just slap them keys, and we're going to go M squared, right? Because we're adding, or sorry, multiplying the modulus. And you know what you want to do to one side, you got to do the other with parametric circle shit. Right, alright, and then you want to add your 2 things, right? You add your 2 arguments, which would be like that, but we're just going to collect like terms and do that. So now what we have is the squaring of this complex number. As you can see, if I make it a little bit clearer, AT, PT, as you can see, the modulus is being squared, right? So if I was to make a circle that was like 4 cos t and 4 sine t, and I just made that like 2 pi. As you can see, it is 4 times the length. No, not 4. It's 2 times the length. It's the length of the first one squared. You know what I mean? Shut the fuck up. Alright. So yeah, it's pretty standard. The angle's doubled, as you can kind of see there. I'll make it a bit clearer by just moving it along. And it will follow the same circle. So if I make this like 2, if I move around the angle, it's going to have the same output modulus. Alright, so now that we've established this, right, how can we put this in such a way that we get ourselves a, what we want, right, to make our thing. Shit. Do I have B defined? I'm gonna use B, okay, cool. Right. B. Alright, so B is going to be our power index, right? Say is B to the power of 1. Hey, actually, this is convenient. Look, like, right, so this is -2 to the power of 1. And let me get over some shit here. Alright, as you can see, -2 to the power of 1 is, as you'd suspect, -2. But what if we were to square it? Well, as you can see, it's 4. But what if we were to cube it? -8. Ooh, do you guys see a pattern? Probably not, because I didn't really take enough time to explain the thing that we're trying to graph in the first place. And once again, I forgot to make this a list, L for list. There we go. Hey, now look at that. I got myself a list. F of X. Speed run. L. I am needing to work on that, right? So, what were we noticing here, right? B to the power of 1, so we look at the X value of 1. We're gonna get -2. Look at that, it's -2. And then we did 2, right? As you can see, it's +4. Look at that, it lines up. Oh my god, it actually worked. And then we do 3, -8, and it was that, trust me. Alright, so cool beans, it all works. So what shall we do now? Well, I think this next step is pretty simple, right? We replace these B's with T's and make it a range to see what our graph looks like. Vote now on your phones as to what it is. Heads up though, just a little tip. It's not a wave. So yeah. Alright, let's say it's -10. And we did -10 to +10, right? You get this spiral. And if you notice, everywhere it intercepts the real axis will actually show up on your little list graph thingy. So that's cool. Right, like, as you see, -2 is there. And +4 is there. Alright, so this is cool, right? You might think, like, that's epic. This is epic, right? I think it's pretty epic myself. Alright. But how do we quickly draw data from this? Well, it is pretty simple. We're gonna make these B's again. Oh, fucking shit. We're gonna make these B's again, right? Alright, and now B. Actually, I might make these T and these T. Alright, so as you can see, moving the B term around. Actually, you know what? Get rid of these T's. Alright, it's just gonna be a point. Now if I move these, alright, so see this point here as it moves around. This is going to be the complex result of your thing. Oh yeah, right, of your, -2 to the power of whatever this B value is, right? And you're gonna get 0.929 plus 2.885 times I. And anyway, you can swiggle this around and play with it, I guess, I don't know. But now the real question is, how the fuck do we, graph this to be a bit more like a proper graph, like this list purple thingy here is. With that, we cannot use Desmos. You'll have to use Microsoft Mathematics. It is, however, really pretty simple because you just do a 3D parametric, not a surface, rather, but a curve, I think it's called. And you just make like 2 of the dimensions, these dimensions that we just made here, and then one of them just simply T. And what that will do is it'll stretch out the spiral. And accurately make your function that you're looking for. So anyway, with all that said and done, I guess that's the end of today's video. I hope you enjoyed. Yeah, another video on the channel. Let's go. Will I edit it? Probably not.